So we're discussing application of derivatives. So let's say we have two curves C1 and C2 as mentioned here, and we are asked to find the angle of intersection of these two curves. So my question is, find the angle of intersection of curves C1 and C2. Now, to find the angle of intersection of two curves, what you need to do is find the angle of intersection of their tangents at the point of intersection. So if these two are curves C1 and C2, what I'll do is I'll draw a tangent T1 to curve C1 at point P where the curve intersects, and I'll draw a tangent to curve C2 which I'll call as T2, which again passes through the point P. Now I need to find this angle theta. Okay, so angle of intersection of curves is basically the angle of intersection of their tangents at the point of intersection. Now let's proceed. Let's say the slope of the tangent T1 is theta 1 and the slope of the tangent T2 is theta 2. So you see that this is a triangle whose this angle is given by 180 minus theta 2. Okay, so my theta is, since this is a triangle, my theta is 180 minus sum of these two angles, which is theta 1 plus 180 degree minus theta 2, which comes out as theta 1 minus theta 2. So this is my theta. If I am able to find this value, then I'll be able to find the value of theta. Now you know that tan of theta 1 is what? Tan of theta 1 is the slope of the tangent T1. Okay. Now the slope of the tangent T1 can be found out by finding the derivative of curve C1 at point P. So if I find dy by dx at point P, then I'll get the of curve C1 basically. Okay. Then I'll get the value of tan theta 1. Similarly, to find the slope of curve or tangent T2, the slope of tangent T2 is tan of theta 2. To find that, again I need to find the derivative of y with respect to x at point P of curve C2. Now these two values can be found out if I know the equation of curve C1 and C2. Given the fact that I know these two values, let's proceed. You know theta is theta 1 minus theta 2. So tan of theta is now if you have idea of basic trigonometry, you know that tan of theta 1 minus theta 2 is tan theta 1 minus tan theta 2 divided by 1 plus tan theta 1 tan theta 2. Now in this case, since we are dealing with the acute angle formed between the two curves, so I'll put a mod sign here. Now this equation, this one, turns out as, if I put the value of tan theta 1 and theta 2 from here, I'll get of curve C1 So this is my value of tan of theta. So to find theta, what I'll need to do is find the tan inverse of this value. So I'll get the acute angle formed between the curves C1 and C2 at the point of intersection. Okay. Now let's take an example where we need to find the angle of intersection. The question is, find acute angle between the curves y equals to x square minus 1 mod of x square minus 1 and y equals to mod of x square minus 3 at point of intersection given that x is greater than 0. So the question is, find acute angle between the curves y equals to x square minus 1 and y equals to x square minus 3 at point of intersection given the fact that x is greater than 0. First thing which we need to do is that get rid of the mod sign. So to get rid of the mod sign, what I'll do is I'll square it. Y square equals to x square minus 1 whole square, and here y square 3 whole square. Now what I need to do is I'll equate both the sides. So since we need to get the point of intersection, so when I equate this two, I'll get x square minus 1 whole square is equal to x square minus 3 whole square. Bring this to this side, so I'll get something of the form of a square minus b square, which I can write it as a plus b into a minus b equals to 0. Okay, so a minus b, this is a, this is b. So x square minus 1 minus x square plus 3, this is a minus b, and a plus b will be to 0. So here I'll get 2x square minus 4 equals to 0, or x is equal to plus minus root 2. Okay. Now, can I take x equals to minus root 2 in this case? The answer is no, because I have a condition given that x is greater than 0. So my only solution is that x is plus root 2. Okay. Now, let's define the curve. You know that if I have an equation y equals to mod of fx, then this I can write it as fx if fx is greater than 0, and this one I can write as minus fx if fx is less than 0. This we do to get rid of the mod sign. Okay. Now at x equals to plus root 2, this curve c1 is, if you put plus root 2 here, you will get this as 1. So this is positive. Okay. Neglecting the mod sign, this inner part only is positive. So this curve can be written as x square minus 1 at root 2. But this curve is negative. You see, root 2 whole square is 2 minus 3 is minus 1. Okay, this inner part is minus 1. So to get rid of the mod sign, I'll have to write this curve as minus x square minus 3. Okay. Okay. Now to find the acute angle, what we need to do is we need to find the derivative of both the curves, and we need to find the slope or the derivative at the point of intersection. So let's differentiate both the curves. It's 2x and here it's minus 2x, right? At point of intersection, this will be 2 root 2 and this will be minus 2 root 2. Okay. Now since we have found out the derivative, now the next process becomes very simple. We just need to put the values. We know what the formula for the angle of intersection is. The formula is tan theta is mod of something. What is that something? Dy by dx of curve C1 minus dy by dx of curve C2 whole divided by 1 plus dy by dx of c1 to dy by dx of curve c2, right? Okay, put the values. 2 root 2 minus of minus 2 root 2, 1 plus 2 root 2 minus 2 root 2 mod. So you get this as 4 root 2 by 7. So my answer is 4 root 2 by 7. Okay.